Before modern cloud computing, engineers logged into consoles and manually clicked through menus to launch servers. To speed this up, they adopted Infrastructure as Code, or IAC, a method of managing and provisioning computer data centers through machine-readable definition files, rather than physical hardware configuration or interactive configuration tools. Industry-standard IAC tools rely heavily on static data formats like YAML or JSON. These are structured text formats used to transmit data, serving here as a fixed hard-coded blueprint of the desired cloud state. As architectures shift from single servers to highly distributed microservices, small independent services that communicate over a network, these static blueprints balloon exponentially into thousands of fragile lines. The tools originally designed to save developers time have become difficult to read. Managing these massive files now serves as a primary source of technical debt. Static configuration files have a core limitation. They lack native programming logic. You cannot write a loop, declare a variable, or use a conditional statement to adjust the environment based on changing data. This creates operational friction. A single missing indentation in a YAML file might go unnoticed until minutes into a long deployment process, causing the entire operation to fail. To manage this, developers are shifting towards treating cloud infrastructure exactly like application logic by using full-fledged programming languages. Dealing with modern cloud scale requires the flexibility and predictability of actual code rather than just static text. The AWS Cloud Development Kit, or CDK, is an open-source framework that lets developers define cloud resources using familiar languages like TypeScript, Python, Java, or C#. This integrates infrastructure directly into the IDE, the integrated development environment where engineers write their software. This provides instant access to inline documentation and autocomplete as they type. Using code enables type checking, a feature where the compiler verifies that data types are used correctly. It catches structural errors and misconfigurations instantly before a deployment is ever attempted. Code also brings the power of native logic. A standard for loop can iterate through variables to instantly generate identical, distinct architecture clusters for development, testing, and production environments. This allows developers to remain within their established workflow, using their preferred tools to build both the application and the infrastructure. The CDK organizes resources into constructs, fundamental, reusable building blocks. Layer 1 constructs act as raw materials needing manual configuration. Layer 2 constructs automatically package common boilerplate and secure defaults. Layer 3 constructs are architectural patterns, provisioning an entire back-end ecosystem in a single line. This hierarchy allows thousands of lines of fragile configuration to be compressed into simple, shareable, and secure code snippets. While the developer writes in code, the CDK doesn't bypass the standard AWS provisioning engines. It serves as an intelligent layer on top of them. Synthesis generates a CloudFormation template from a CDK application, translating high-level code into standardized JSON or YAML. A diff tool lets developers preview exact infrastructure modifications. Once verified, the template is provisioned on the AWS cloud. The framework acts as a translator, providing a modern interface while relying on battle-tested deployment engines to handle the heavy lifting. We have moved from managing static text files to engineering dynamic, testable infrastructure. This shift means senior engineers can codify organizational best practices into constructs and share them across teams like standard software libraries. In the next episode, we will set up our local environment and write our first lines of CDK code. By treating infrastructure as software, the CDK has bridged the gap between engineering and cloud operations.